Hi, everyone. My name is Joshua Buck. I'm here with Lashanta from Seed Studios. Today, Edge Impulse and Seed are presenting a demonstration about the SenseCAP A1101, which is a LoRaWAN vision sensor. We're going to go through what Seed has to offer, why it's a good camera system. We're going to do a demonstration of Edge Impulse and then show you how you can get more information to get started. Lashanta, your presentation.
Thank you, Josh. And so hello, everyone, and welcome to our workshop today. So my name is Lakshanta, and I'm an application engineer at Seed Studio. So I have been, my main areas of focus are embedded systems, IoT, and AI. So if you want to connect with me, you can check my LinkedIn, Twitter, and also check all my works on GitHub. So Joshua, could you please introduce yourself?
Yeah, my name is Joshua Buck. I'm a senior solution engineer here at Edge Impulse. I work very closely with partners like Seed Studio to get devices integrated to Edge Impulse and make them available to users so that they quickly can get models deployed onto these devices, AI models. You can find my LinkedIn there, and if you ever need to reach out and have any questions, please contact us at hello@edgeimpulse.com.
Thank you, Josh. So now I will briefly give an introduction about Seed Studio before we move on. So Seed Studio is an IoT hardware partner, and we have been in the industry since 2008. So we have been the IoT hardware partner for more than 470,000 global IoT developers. So we closely work together with leading chipset companies, and we provide thousands of open source modules for rapid prototyping. And also we help scale up projects with agile manufacturing services and global distribution networks. So actually we recently announced a roadmap of an advanced perception system of modules, devices, and solutions. So through this roadmap, we aim to bring system integrators a full toolkit of sensing, networking, and edge computing to leverage digital transformation for industries. So actually this roadmap was introduced in the annual product release that we had a couple of months ago. It was like on March, on the Pi Day, March 14th. So that catalog is ready to download for you guys, so that you can also go through all the products that we are releasing in this year. So at the end of this workshop, I will give a link to that catalogs where you can go through all the products that we offer in 2023. So focusing on embedded AI, we are also the NVIDIA's elite partner, and we provide full product lines, as you can see, from imaging sensors, LiDARs, development kits, carrier boards, and full systems. So we are also an approved designer of a Raspberry Pi, and we try to address custom solution needs through hardware customizations. And we also partner with like different ISVs and algorithm communities to deliver more AI applications and also accelerate these digital transformations with low code and providing the fullest support. So if you want to learn more about Seed Studio, you can visit seed.cc, or if you go to seedstudio.com, you can explore all the products that we offer. So this is the SenseCAP A1101 that we are going to be mainly focusing on during this workshop today. So I have this product with me today. It's the SenseCAP A1101, this device. So this is a LoRaWAN vision AI sensor. So this is actually, this has a camera here, and the camera is HiMax. It has a HiMax camera with 400 megahertz DSP and a maximum frame rate of 640 by 480 and 60 FPS. And also this device needs very low power to run, and also because of the LoRaWAN connectivity, it makes sure that you can have a long range transmission, right? So when it comes to the power, it can work as low as 2.3 microwatt hour power consumption. And also it provides high data security because it's everything is happening at the edge. You're not sending the data to the cloud. So all the processing, all the AI inferencing is happening at the edge. So you can make sure that your data is secure. And also we have developed a special dashboard called SenseCAP dashboard, where all this sensor data, right? So once this camera captures the objects, that those detection results will be sent to a LoRaWAN gateway, and the gateway will send the data to an online dashboard. And we have made this dashboard easy to visualize all the results, and we have also made this entire workflow easy for the customer, so that it's very easy to deploy different models to this device. So that's what we will be focusing on in this workshop, on how to easily deploy models and then finally view the results, inference results, after sending the data through LoRaWAN. And also one more thing is that this device is it's an industrial, it is according to the industrial standards, where it can withstand operating temperatures between -40 and 85 degrees Celsius. And also it has an IP66 rating. So it's very suitable to be deployed in industrial and other outdoor scenarios. And also you can easily scale this device. It's easily scalable because of one of the reason is it's easy to deploy the device, so which makes this easy to scale. And also it will really help businesses to bring down the maintenance cost as well, because we have made the entire workflow easier. And if you want to learn more about this SenseCAP A1101, you can visit this URL, or you can scan this QR code to learn more. So when you buy this SenseCAP A1101 from our website, it will be coming, there'll be a model coming out of the box, which is people detection model, which is trained on the Ultralytics YOLO V5 algorithm. And so after a few months of releasing this product, we thought of partnering with Edge Impulse together, so that we can bring the Edge Impulse algorithms, such as the FOMO algorithm, so that we can have even a better inference performance than YOLO V5 on the A1101, because Edge Impulse mainly focuses on providing these models to fit embedded devices with low power and low hardware resources. So that we will be focusing on the Edge Impulse FOMO object detection algorithm in this workshop. So this is the out-of-the-box experience once you buy this A110 product. So as you can see, this is the workflow. So first, you use this device to use the camera, the onboard camera on the device, to collect, to prepare a data set. You collect the images through the camera, and then you annotate the data set that you prepared, or else you can also obtain a public data set, which are readily available online. And then after you have prepared the data set, you can train the model, and we have ready to go Colab Google Colab workspaces, where you can just like click through the code cells and easily go through the training process. You don't need to write any kind of code. So we have made it easier in that regard. And also after the training is finished, it will generate a .uf2 file. So you can easily deploy that UF2 file into the device. So once you connect this device to the computer, it will show up a device, USB mass storage drive, and you can easily copy and paste the UF2 model file to the device by dragging and dropping to the mass storage device that is created after you connect this device to the PC. So that is So Josh will be explaining more about all this stuff. And so after because the edge impulse workflow is also quite similar when it comes to the UF2 model deployment, because in edge impulse also, once the model is trained, it will export a UF2 model, just like this YOLO v5 workflow that we have here. So after that model is deployed, so we can use the SenseCAP Mate app to visualize the results, which I will be showing later. So Josh, I think yeah, so for this one, for the SenseCAP A1101 getting started wiki, we have prepared so that so that's for the out of the box experience. So if you want to replicate on your side using the YOLO v5 algorithm to train and detect the objects, you can go through this getting started wiki. So yeah, so Josh, I think Josh will be explaining to you guys now how the edge impulse workflow would look like on this A1101 and how it will all work. So he will go walk through step by step in the process. So over to you, Josh.
Excellent. Thank you, Lashanta. I'll need control of the screen, if you may.
Okay. Yeah.
All right. So Edge Impulse is a platform for model development, right? And we do focus on optimizing for edge devices, anywhere from Cortex M0 to Linux-capable devices like A72s, x86s, Raspberry Pis as well. It is a royalty-free business model for using our platform. We have a free tier for developers and then an enterprise tier for more serious model development and model training. But once you develop that model, we really strive to keep everything open source. We give you access to the training scripts, we give you access to the data that you've used, right? And the model is yours. There's no deployment licenses once you got that model. So take it and run wild with it. But it's really important that we try to show what's going on behind the scenes, because we do have a very graphical interface, but we try to be very explainable about what's going on with the boxes, show off what's going on with the DSP algorithms, for example, as well as the model and training loops. The general Edge Impulse workflow follows very much any kind of model development workflow, right? You're going to need to have some sort of data. You're going to have an algorithm or a model that you wish to train, right, or work against. You're going to test it, and then what makes the key difference between regular model development and edge model development is we want to deploy it for various targets, right? And we try to do this in a way that there's no to low code for the user, so that you can quickly see results on the device, right? That you're not just getting simulated results, but actually seeing the device run that particular model, how fast it's running, and how well it actually does inferencing. The workflow is kind of listed here on the bottom, where today we're gonna walk through data collection using Studio and the CLI tools. We're gonna design a model, and really we're just gonna pick a model from a list and then train it. I'll show you where you can get test and validation results, and then we are going to deploy back to the edge device, in this case, the SenseCAP A1101. There's also this idea of active learning, or not active learning, but continuously kind of improving your model over time, right? And one of the things we really strive for is that you can get your data back onto a storage bucket of your choice, like an S3 bucket, and then kick off a whole new model development and training pipeline so that you can make your models better over time. And we call that active learning. So just like Lashanta showed with that YOLO v5 and the Google Colab workbook experience with that link, we are going to go follow this very similar process of collecting data, building and training a model, and deploying it onto the device. Here I've listed some of the key commands that you're going to need to know from the Edge Impulse CLI, such as the Edge Impulse daemon and Run Impulse as well. And then I'm going to walk through Edge Impulse Studio. Edge Impulse can be reached at edgeimpulse.com. We have a number of getting started projects that you can come over here to the developer tab. These projects are sorted by the type of sensor that they may be using. For example, we have a lot of accelerometer projects or a lot of image projects as well. The model in choice today is FOMO. FOMO is a MobileNet-based model where we change the classification head. And instead of doing a bounding box, we do a kind of more of a centroid. It's been used to identify a lot of different things. Today, we're going to be focusing on face detection, so trying to get a dot on my nose. But it's also been used for detecting cars or nuts and washers on a conveyor belt, for a manufacturing setting. livestock counting, bee detection, number of bees in the screen, things like that. So it's a very capable model, and it's very much optimized for devices like the SenseCAP. A little bit more information about how to get started with the SenseCAP can be found on our documentation page. There's an entry under the Devices tab. You do have to walk through these instructions to get the SenseCAP working with Edge Impulse Studio. It does require a few dependencies, which I've already have installed on machine, so that I can go through this demo a little bit more quickly. But you do need to install the Edge Impulse CLI. And then you do need to update the firmware on the device. It involves connecting to SenseCAP via USB-C cable and following the instructions such as holding down the boot button, and then working through a firmware uploading tool called Buffalo Lab. Buffalo Lab instructions are shown here with a couple of key screenshots on where you need to connect to the MCU, choose a particular firmware file, and then create and open up a UART and then download to the device. Assuming you do that all correctly, then you're basically ready to get the Edge Impulse firmware on the device and getting it to connect to Edge Impulse Studio. So I'm going to start from that standpoint, assuming that you have run through the Buffalo Labs firmware update utility. You do need to download the Edge Impulse firmware. Like LaShanta said, this is a UF2 file, right? It comes as a zip file. I've already previously downloaded it. I have it here in this file, in this folder. I'll show you how to get the SenseCAP into right configuration here in a second, but how this firmware was developed, and again, in keeping with these open source principles, we do have a public GitHub repo that has the firmware for both a Grow Vision product, which is another Seed Studio project that we have, a product that we have in the Edge Impulse, and for the SenseCAP A1101. The link is found here, Edge Impulse at GitHub, and then the Grow Seed, the firmware Seed Grow Vision AI products. And this is how this firmware was developed. So to get this firmware on the device, I have the device connected to my computer via USB-C. I will double click the button on the side. I come back here to the picture. It's this button right here. We are going to double click it this time. And it'll become a mass storage device. And we'll have this D drive here. So I'm going to take this firmware and drag and drop it into the device. And now we are transferring the firmware file over. And when the device clears from the screen, we'll know that we had a successful download. In this case, we did not have one, so it's going to ask us to try again. So we'll just go ahead and drag and drop it over. And when the mass storage device clears, that means you have had a successful firmware download. And then you can see that we got this Google Chrome notification says that, hey, we detected that this USB device has been connected. We're not going to go through that. What I am going to do is show you how to get to this point where you can use the Edge Impulse daemon to connect to a studio project. What I do want to show off is from one of these projects, we have FOMO, a project called Face Detection. And I'm going to use this as our starting point for today. I'm going to choose the 96 by 96 color image RGB. And this project is a collection of data, mainly images that show different faces, where we can draw bounding boxes on the images. And this will be used as both the training set and a test set for model training. Again, the model of choice here is FOMO, which has a which is based upon MobileNet. We are doing it at 96 by 96 resolution. And then you can see this particular model trained at 84 for a quantized version and a float version of 85. In order to work with this particular project, I do need to clone it into my personal space. This can be chosen up here by this particular button at the top. I've done that. That takes a minute to do. So I've already done that step before. But you get the project, but in an editable state. The project public is the public project is not editable, but the one that you can have in your personal area of Edge Impulse, you can start working with it. I'm going to connect to the project. I'm going to make sure that my SenseCAP can actually be used to take data. That's very important to try to use the device that you're actually going to run inferencing on to also take the data from that device. I'm going to go grab a developer key so it's easier to connect straight to the project. I'll go copy this from the dashboard, and I'll go over to my command window, and type in edge impulse daemon -- API key, and then the API key itself. What this is doing is connecting the SenseCAP, which doesn't have connection to my Wi-Fi network, through the USB cable and using my computer as a network forwarder to edgeimpulse.com. You can see here it has this link. We can copy and paste this if you want into the browser tab, but notice the project number 214554 is the same one that I have here. What this does is now we have the SenseCAP connected to Studio. I've previously named it Josh, and it has different camera options like a 64x64 image capture, 96x96, etc. And you can see that it has a green light and that it's connected right now. I'll come over to data acquisition. This is part of the data collection phase of that Edge Impulse workflow. And we can make sure that the device is connected and actually sample different images, right? So I'll go ahead and choose this 64x64 image, and I will start sampling from the camera feed. It'll display an image here in just a second, and we will have the device connected up. Let's see. Looks like the device decided to disconnect. We'll just double check that really quick. Yeah, looks like we have a network connection problem. We will clear out and try it one more time. Great. Okay, we have a green light. Come over here to data acquisition and go to the camera feed. Great. So you can see I'm in front of the camera, right? I have it on a lower resolution 64x64. It doesn't really matter which one you choose because you can still train a face detection algorithm so long as you have the right data in front of it. So I'm going to click on sample here. What it's going to do is take a screenshot from that and put that in either the training set, which I'm selected in right now, or the test set. And it also gives me things to label, right? It doesn't know what to do with this image. Okay, this is an object detection algorithm, so we're gonna have to draw a box around the face. So we could take a number of different images here in different settings. Remember, this happens to be that we're working on faces. This could be cars, this could be bees, this could be any kind of object that you want to track and try to count and frame and locate it within the frame. So I've taken a few different images. I'll come over here and added them to the training set. If you want to add them to the test set, you can go and just click on a test tab and do the same kind of process where you sample and add it to the test tab, test data set. I'll head over here to the labeling queue. And what it's asking, this is from another camera image, but you can come up here and then drag a box around it. And you can say, hey, this is a face. It's very important to try to get your labels correct, that they are case sensitive, right? So if you have a capital F in face or not, those will actually interest two different labels. So I'll set the label here. And then I'm going to save this label, but I am going to track between frames. So it's going to try to find the next face in the frame. This happens to be a very small image, so 64x64 versus a high resolution. So it didn't do a good job tracking there. So I'll save labels. And then there, it got me for that one. And that one as well. Great. So since we cloned the project, we already had a number of different images in this data set. For example, this I believe comes from the wider face data set. And then we also have augmented or added to it images from our particular camera, right, the SenseCAP device. Once you've collected your data, right, or acquired it and uploaded it to Edge Impulse, there's also a way to do it via the upload tool, right? You can go upload data from websites or from a zip file, for example, and then go and annotate it with your labels. But once you've done that data collection, you're now ready to do your impulse design. An impulse is a collection of, or describes a process of how to get data from a sensor, process it, run it through a model, and then what kind of features or results you're going to get from that model. For image data, the processing is pretty simple. We either do just RGB or grayscale. You can customize these blocks. So let's say that you want to do edge detection or pose estimation, or do another type of more, denoising algorithm for images, or change the color shifting values or wider brightness. You can definitely do that with these processing blocks, right? What we do in the background is a Docker container. You can write Python or C code. And then if you can replicate it on a device, that means your model is just going to have that much better data to work with. So we're going to take an image data, anything from the image test or training set. We're going to process it to 96 by 96. We will fit via the shortest axis so that we're going to kind of squash the image down, right? We'll keep it as grayscale or RGB, and then we're going to choose our model, which happens to be a face detection model. When you add a processing block, it's important to generate features. What this does is run it through that processing algorithm. So in other words, we take all the high resolution or low resolution data and get it into a data set that has that 96 by 96 pixel arrangement. So we'll save this parameter. So you can see here I'm choosing grayscale. Here's the raw features of this particular image. We can go look through all the labels. In this case, there's only face. And we can choose different images and see how they would process out. So for example, this data set happens to be a color of 3 faces, and we can use it to grayscale images as well. I'm going to go ahead and save the parameters. We'll just go over here to generate features, and then we click on generate features. This spins up a job in Edge Impulse as a container, and it's then going to go process that data set. What it gives us here in the Feature Explorer is showing a kind of subset of the samples. This one doesn't look all that interesting because it just has nothing but face detection, so they're all one color. But on other projects, it gets really interesting if we look at other FOMO projects, for example. Let's say choose washer and screws. The feature generation or the Feature Explorer will show different portions or different all the different inferencing labels that you may have. So for example, these happens to be screws, and then over here you can see that there's a nice grouping of washers as well, and it really shows you how different those the model's going to see that, and it probably makes your model that much easier to go detect the difference between objects that you may be putting into that model. So let's come back over here to our face detection. We have it here in this tab. It's just about to complete the job, right? We should get a Feature Explorer that we can go and look at different images and see how they appear. Sometimes this is also a good place to see if you have miscategorized or chose the wrong label for a particular image. Perhaps you labeled a screw a washer a screw, or you may have identified a duck as a face in an image. This is where you can look for outliers and try to understand what's going on with your data set. Once you generated features, you come over here to the object detection algorithm. We have a number of different models you could choose from. In this case, we are choosing FOMO. The training cycles is how long or how hard the model is going to work to get the accuracy that you hope to achieve, right? So it's going to run through 70 iterations of training. There's some advanced settings here, such as how much data do we want, or how many samples of the training set do we want to save for validation, and then whether or not we're going to profile a quantized model like int8, etc. The model architecture can be viewed in the background, so we can go over to those who happen to be familiar with Keras. You can go look at the Keras code and see how the model is constructed. Or if you want to edit the block locally, you can actually get access to that Docker container, and then really work with the training code if you have a particular need to edit how the model is actually trained. We're going to go back to the Visual Simple mode, and we're going to kick off a training. Training can take a few minutes. Again, Edge Impulse has really 2 tiers, right? 20 minutes of data, 20 minutes of training time, 4 gigabytes of data, and then otherwise we ask you to come over to a paid account. This job will take only a few minutes. We can see in the Jobs tab how long it had trained in the past. About 1 minute. I'm not going to wait that long, so I'm going to go over to a project that I have trained. Same project, but it's already been trained, and we're going to go look at the accuracy, right? This one, in this particular data set, had a few images from the camera and a lot of images from the wider face data set, and it trained at 88% for a quantized model. It's really important to go look at your model testing results. In other words, run it through a data set that it hadn't seen before during training. And you can see that sometimes the accuracy is not as good as the training had done before. And we can go and look at where it may have done bad and not inferenced correctly. For example, this data or this image was sent through the model And while it still detected a face, it had a pretty low accuracy and pretty low confidence that that what it saw was actually detected as a face. Whereas this one came out pretty obvious. It's a pretty funny picture. This is a key area though, because what you can do is you can change the confidence threshold for a model. In this case, we're saying anything where you believe that you see a face is more likely than 50%, or for that particular label, go ahead and label it as such, right? These settings that you put into Edge Impulse, like the 96 by 96 or the confidence threshold, get actually compiled into the binary. So when you run on device, it's actually using settings from Edge Impulse to influence how the models run on device. I'm going to go ahead and take this model as is, even though it's not doing such a good job on the test data set. I just want to see how it runs on device. There's two different deployment options for Edge Impulse. There's the ability to create libraries, and then there's the ability to get compiled firmware, a binary, out from the device. Why you would choose one over the other? To create a library or to work with a library such as C++ is if you have a project that works for already a device that may or may not be supported in Studio, you can do the porting effort for it, or you can take one that's already been ported, but you can go integrate it into your existing project. Edge Impulse has an SDK, and there's also an API for the website as well. And the inferencing SDK is basically how we get result structs out from the model, right? It gives you the bounding boxes, it gives you information about what the inferencing results are, things like that here in the result struct or result bounding box struct. Alternatively, if you don't want to go and use make or whatever IDE of your choice to build a model and get it on the device, we provide a simpler way. You can click on a device like the SenseCAP and click on build, right? This build is going to launch a compilation. It's going to take the settings from the studio, such as, how we're going to go shrink images from the raw camera sensor, what kind of confidence thresholds we're going to work for, and which particular model we're going to choose, either a float or a quantized. In this case, we chose a quantized model, and we're building it for the device. So I'll let this job run. All right. We enable all warnings so you can see, how that code's actually being built into the model and where things might be of interest to go look at, just in case you do see an error. Again, where we're building this model from is we're taking the TensorFlow-like model, compiling it down, and then compiling it into the code from this GitHub repo and producing a binary from which you can deploy onto the device. We'll give it a second here to finish the building, and it's going to give us a zip file with another UF2 file. All right. What we do is we give instructions about how you need to get to device in bootloader mode. Remember, we have that button that we need to double click. And then it also gives you instructions about what command you need to run once you got it onto the device. So I'm going to save off this file. We'll click save here. I'll go open it up and we'll extract it. Okay, so we have this UF2 file. I'm going to have my device still connected to Studio, so I'm going to go ahead and cancel this command. Actually, I'll go ahead and just close the terminal. And we will put the device into bootloader mode. So double click. Okay, mass storage device, and we will drag and drop this trained model onto the device. Our trained binary, actually. Excellent. We had a successful firmware download. We will launch a command window. Again, we have previously, outside the webinar context or outside the workshop context, installed the Edge Impulse CLI tools, which is available via the doc page. But we will go ahead and run this impulse on the device. So Edge Impulse, run impulse, and then this dash debug basically will move the image data from the device onto a little web page on your computer so that you can actually see a live feed and its results. So we'll go here, and it's going to start classification. Before I show you that image, what I want to describe here is what's going on the screen. We are showing the predictions of the model and printing them to this terminal. It tells you how fast the DSP algorithm's running, right? How quickly it's resizing the image. How long it takes to run the model, basically the classification time. In this case, it looks like it's averaging around 103 milliseconds. And then the predictions. In this case, this model only predicts one value, face, right? And it's trying to show you where in the image that box is, or where the center of that object is, because this is a centroid kind of detection algorithm, or model, sorry. If you had more classifications, let's say try to detect face and hand, it would show you two different results, or three different results, or four different results for that. This is an output from the Edge Impulse result structs, right? From the bounding box for this device, right? So if you are working with the code, it's the same code for this device as well as other devices, right? It's the same inferencing struct that you may have seen before. Let me show you that web page, right? So at the beginning, it gave an IP address. I have already been using that IP address. And here I am, right? You can see that it's actually detecting pretty well on the device, right? So sometimes it walks through the detection. FOMO is sensitive to distance, right? If I'm too far away from the camera, it's not going to do a good job. If I'm way too close to the camera, FOMO doesn't do a good job. But if I'm about a pretty medium distance from the camera, it does a pretty good job of detecting and it can follow me along. And the inferencing speed's pretty good, about about 1/10 of a second for running this model and doing an inferencing result run every time. So, in sum, we've walked you through creating a project, working or cloning a project from the public projects page, right? Connecting your device using the Edge Impulse daemon command, doing labeling and bounding boxes of those data, training a model, looking at testing results, and then showing how different that can be for on-device performance as well by not having to write any code at all. Thank you, Seed, for having a great product to work with. That concludes my demonstration. Lashanta, if you want to continue from here, it'll be your presentation, just a section. Let me hand you over the screen.
Thank you, Josh, for the excellent demonstration. I think everyone was able to follow along with you to get it up and running on the device and also inference on the device. So next up, so now what we have is we can do the local inferencing and see all the results locally, right? So I will share my screen. So the next section will be about how to connect this device to a LoRaWAN gateway and then send all the results to the SenseCAP cloud, the SenseCAP dashboard that I mentioned before. So I will. So this is the content that we'll be talking. I will talk about it later in this workshop. So so about sending the data to the LoRaWAN. So just stay tuned with us so that I will explain step by step on how to do this. So for the Edge Impulse community supported boards, so if you go to this particular website, docs.edgeimpulse.com/docs, you can see all the community targets supported by Edge Impulse, and we have a couple of seed products already listed here. So we have the seed bioterminal, we have the seed recomputer Jetson, and recently we added the seed shower boards. So if you go to these links, it will show you how to get started with the Edge Impulse Studio with these devices. So basically, like, it will go to the wiki pages that we have created for this board, because since they are community supported boards, we are the ones who are like keeping the maintaining the project and maintaining the documents for these boards. So if you click on this, it will direct to the wiki pages of Seed Studio, where the entire workflow of the getting started is explained here. So so that is it about for this workshop. And so this is the catalog that I mentioned in the very beginning of this workshop. So if you scan this QR code, or if you visit 2023.seed.cc, you can access the product catalog that we have released, and which includes all the products, exciting products that we'll be releasing in 2023. And also you can visit, you can reach out to us through social media. We have LinkedIn, Twitter, Discord, YouTube. We post exciting like projects and videos on these platforms. And also we have a Hackster Project Hub, where we have a big community where they share their projects using our products. So yeah, Josh. So we are now to an end to this for this workshop, and now what we will do is I will come back to the LoRaWAN section of how to set up the device with LoRaWAN and get it up and running and send the data to the cloud. So as I mentioned before, so this is the LoRaWAN networks. So we can connect this device to different LoRaWAN networks. So we can either connect because there are different LoRaWAN networks available out there, such as the Helium network, the Things network, right? So because we have made the entire process of connecting to LoRaWAN much easier if you have the SenseCAP LoRaWAN gateways. So I will show you that the gateways that we offer. So this is one gateway that we offer, the SenseCAP M2 light hotspot, this LoRaWAN gateway. And once you have, so this is actually connecting to the Helium network. And once you have this device connected up to the Helium network, it's very easy to connect this A110 device with this gateway. You just have to scan the QR code on this device. I will show you later about that. And once you scan the QR code, the device will like the device gets added to the network, just like that. But if you are like, you can also use existing public gateways that are available. But if you use them, then you need to specifically use use the parameters such as the ones that are written here, the EUI key and the app key. So you need to do more like steps and configurations if you want to connect with the public ones. But for the seed ones, seed SenseCAP LoRaWAN gateways, we have made it much easier for the setting up process. So this is the Helium, and we have another gateway, the SenseCAP M2 multi-platform gateway, which supports multiple LoRaWAN networks. So this one actually supports the Things network and other LoRaWAN networks as well. So you can visit this our Bazaar page to learn more about these gateways. So now what I will do is I will So first of all, you want to have the SenseCAP Mate app installed on the phone, on the mobile phone. So I will open up a share of my phone screen. Yeah. So sorry. It's a little slow. Okay, I will connect to my phone again. It's going to be faster that way. Okay, so now I'm connected. Yeah, okay. So now this is my phone. So actually the SenseCAP Mate app is supported by both Android and iOS. So you can simply visit the Google Play Store for the Android and the App Store for iPhone, and you can just search for SenseCAP Mate. So once you once you search for that, you will be able to see the app and you install it. So after you installing, you can see I have installed the SenseCAP Mate app already here. So I will open the SenseCAP Mate app. So actually, once you open the app, it will ask you to log in. So now here I have already logged in to my account. So it's easy to like create an account. You just like enter your credentials and like give it a username and a password, and then you can log in. Like create an account and then log in to your account. And then after logging into the account, you want to go to the device section, and then there's this little plus sign at the top right corner. So you click on plus sign, and then you select this add device. And here now you can see it asks you to scan the QR code on the device. So the QR code that I showed before, so I just like point this to that. Yeah. So now you will see this one, and you can give it a name. So I will name it as Vision. Sorry, name it as Vision AI, and then click next. So you can select the location, set the location, and then confirm. So now the device is added to the device list. So after the device is added, now we want to configure this A1110 device to communicate with the LoRaWAN gateway. So now what I have done is I have flashed the same firmware that Josh has flashed before during this workshop. So see, like I have like connected to the USB Type-C connector, a USB cable to the computer, and drag and drop the .uf2 file that is generated after the Edge Impulse Studio like training process. And I have used the same model file from Josh, which can detect the phases. So it is already now loaded to the device, the firmware. And now what we will do is go to in this app. You need to select the Vision AI sensor block. This block, select it, and as so you can see, like we have mentioned the steps that you want to follow in order to set up the device. So first step would be, as it says, like you need to press this button like for 3 seconds. So I will press it 3 seconds. One. Yeah. So once you do that, it will enter this mode where the button keeps blinking in a constant manner. And once it's blinking, so you need to click on setup button, and now you can see the device shows up on the phone. So actually you need to make sure that you have also turned on Bluetooth on the phone. The Bluetooth and also the location services should be turned on. Yeah. So because for this connection to happen for the between the phone and the A1101, it's using Bluetooth for this configuration for the yeah, to make the configure to configure the device. It's using Bluetooth to establish the connection. So you click on this device that pops up. So it's loading. And then, yeah, this is a screen which gives you a basic information about the device, such as the model, the EUI, the sensor type, the algorithm. So the firmware version, right? So you can go to settings, and here you can select the platform. So here you can select either the SenseCAP for the Things network, SenseCAP for Helium, the Helium. So these are the, so SenseCAP for Things network is the, so you need to select this if you have set up a SenseCAP gateway that I mentioned previously. And also SenseCAP for Helium is also related to the gateway, like the SenseCAP gateway. And if you want to connect with public LoRaWAN networks, then you need to select Helium or the Things network, or you can, if you want to connect to other LoRaWAN networks, you can just select other platform. So in this case, I'll be selecting SenseCAP for the Things network, because I have set up a gateway that is connected to the Things network, a SenseCAP gateway, SenseCAP M2 LoRaWAN gateway. So I have selected that. And for the algorithm, we have selected the object detection, because you're using the FOMO object detection model that Josh trained before. And for the AI model, it should be like this, user-defined one. And for the score threshold, just keep it as default. And the frequency plan is very important because you need to make sure that you match this frequency band with the frequency band that is set up in the LoRaWAN gateway. So right now, the gateway that I have set up just beside me is using the US 915 frequency band. So for that band, so if you're using that US 915 band, then you need to make sure that the SenseCAP A1101 is also configured for that band, US 915 band. So only after that, the device will connect to the LoRaWAN gateway. Because if the frequency bands do not match, if the A1101 and the gateway bands do not match, the data will the device will not provision with the the device will not connect with the gateway. So that is also an important point to keep in mind. And also for the packet policy, just keep it as default. So what we will do now is we will go to general and just press this button, detect, and then just I will point to my face to try this. So you can see 0.93 confidence. Yeah, so that's the confidence score for the object. So it's now actually detecting my face. And let me. So it's detecting my face and it's showing up the confidence score for my face. So actually, to show this in a live preview, what you want to do is you want to connect this SenseCAP device to the computer via the USB Type-C cable. So once if you connect this to the device, USB Type-C, I'm connecting to it. Yeah, and then you can visit this URL. Yeah, so files.seedstudio.com grove underscore AI underscore vision and then /index.html. So you can visit this this URL. Yeah, and then so you can see. Oh. Yeah. So you first visit this URL. Okay, I will reopen my web browser. Let me do that. Okay, so this is the, because before my device is already connected, so I just want to go just start fresh from here so that it will be the same output for you as well. So this is the web URL, and once you after accessing this, you just connect the Type-C cable to the device. Okay, now I connected. So after connecting, you can select this button, connect, and select the device, SenseCAP A1101, and click connect. So after you do that, so now it's showing, yeah. So now you can see, it's detecting my face. I will just be on the frame. So a little bit further, yeah. So as it's detecting my face, if you check the SenseCAP Mate app, you can see the same results displayed here. Let me. Yeah. So yeah. So now it's showing up on the SenseCAP Mate app and also on the live preview. So now if you want to send this data to the LoRaWAN network, so now because we are only, so the SenseCAP Mate app is only showing the data from the Bluetooth connection established between the device and the phone. And for the web preview, it's also like local right now. So if you want to send, so if we can disconnect the USB cable right now, and if you close the SenseCAP Mate app, so it will, yeah, so I will show you that. So let's go to the Mate app. Yeah, so also there's one thing that I failed to mention, and that is the uplink interval. So you need to set this up. The uplink interval means like how many intervals the data is sending to the SenseCAP to the LoRaWAN gateways. For example, if you set this uplink interval, now I have set it up to 5 minutes. That means every 5 minutes, the SenseCAP A110 camera will start, and it will do the inference, and will send the results to the LoRaWAN gateway, and then to the SenseCAP platform. So after sending that, after it will go into a deep sleep mode to save power, and then after 5 minutes, it will again open the camera and then do the detection inference and then send the results. So actually for this part, the minimum you can see should be 5. So please input an integer between 5 and 1440. So 5 is the minimum, 5 minutes. And yeah, so what we will do is we will go back to this, and then I will close the SenseCAP Mate app. So as soon as I close it, let me, yeah, as soon as I close it, it will open the camera and send the results to the gateway. And also you can click this button, the button that I mentioned before. So you can press this button once, and when you press this button once on the device, it will send a data, open the camera and then send the inference results to the gateway. So now we will check out the gateway, whether the gateway has received these results. So go back to the SenseCAP and select the device. Select the device. Select the device that we created before, the Vision AI device. And when you click on it, so as you can see, this the latest result, the 11:48. So right now it's 11:48 in the morning. So 11:48. So you can see the score 0.86. So that is the result that we get. Now this is the result from the SenseCAP platform. So this is a confidence score, right? So if you press this button again after like a couple of minutes after, it will show that confidence. It will show the results, the confidence score of my face right here. So Right now, since it's set up to 5 minutes sending the data, the uplink interval is set up as 5 minutes. That means so it's 11:45, 48. So after 5 minutes, we will be able to see the results here. Or you just press once, and then it will also show the results, because pressing once means you are just like forcing it to uh, open the camera and send the results. Yeah. So that is it about sending the data, the inference results to this SenseCAP Mate app. And I hope you guys were able to follow along with these steps, and also visualize the results on the SenseCAP Mate. And also, as Josh walked through this studio, so if you want to change the model to a different model, not just face, to detect something else like cars or like nuts and bolts, like as shown before. So all those stuff, the results will show, the confidence score will be shown on the SenseCAP Mate app. So that's about it. And yeah, thank you for staying all this way in this workshop. And hope you guys build exciting projects using the SenseCAP A1101 combined with the LoRaWAN network connectivity. So thank you very much again, and I hope you guys have a great rest of the day.